students, I hope you are doing good. Today we shall start the chapter Motion. I hope you are already familiar with the term motion. In our day-to-day lives, we come across different types of motion. We see the birds flying, the ducks swimming, the children running, snakes crawling. We travel by bus, train, bicycle, we walk. Every day the sun rises, the sun sets. That is also due to the motion of earth. If we see the trees they don't move from one place to another, they don't change their position, but the leaves of the trees, they move with the wind. So all these are different types of motion. We can say that some of the objects, they move in a straight line. For example, if you walk straight on a road, some objects, they show circular motion. For example, the earth makes a circular motion around the sun. That means the earth moves around the sun in a circular path. Some of the objects, they rotate. Like if we say the earth, we know that the earth rotates on its axis. Some of the objects, they vibrate. For example, if you are keeping your phone in vibration mode and a call comes, your phone vibrates. So that is vibrational motion. Some objects, they show a combination of different motion. For example, the earth. The earth shows a circular motion, that is termed as revolution around the sun, and also it rotates on its axis, which is the rotation of earth. So earth is showing two motions at the same time. So the motion sometimes is very complex, but it is an inseparable part of our life. So their study becomes important. In this chapter, we are going to discuss about motion in a straight line. That means only those motions which take place in a straight line, we are going to discuss about them. Now let us try to understand motion. What do we mean by motion? Motion is nothing but change of position of an object with time. That means if an object is changing its position with time, then we say that the object is moving or the object is under motion. Now when we are talking about change of position, so we understand, or to understand the change of position of an object, we always need a reference point. Let us try to understand this with an example. Suppose at 11 a.m. you are sitting in your house, and at 12 p.m. you were sitting in this mall, and say the distance of this mall from your house is 2 kilometers. Then how much motion you had, or how much position change occurred when you moved from your house to the mall, what will you say? You will say definitely that there is a position change of around 2 kilometers. You traveled 2 kilometers to reach the mall. Now when we are using this term 2 kilometers, this 2 kilometers we are measuring from the house. So this house is your starting point, or the reference point with respect to which you are deciding your present position or the final position. Now at 1 p.m. you traveled to an ice cream parlor which was around 3 kilometers away from the mall. Now if you want to describe anybody about your position change, then what will you say? Now here you can describe your motion in two ways. First, if you consider your starting point to be your house, then the motion or the position change you had in order to reach this ice cream parlor is 2 plus 3 kilometers, which is 5 kilometers. So the distance traveled from your house to this ice cream parlor is 5 kilometers. But if you consider your starting point to be the mall, then your position changes only 3 kilometers. So you can describe your position in the ice cream parlor with respect to two starting points. First is your house and the second one is the mall, and in both the cases the position change or the distance traveled is different. So we can say that in order to describe the motion of an object, it is very important to specify the starting point. It is the preliminary requirement to state the starting point in order to understand the motion of an. Apart from assigning the reference point or the starting point, you need to be familiar with two more terms in order to understand the position of an object. The two terms are distance and displacement. Distance is the actual path traveled by an object from its starting point to its final point, and the displacement is defined as the shortest distance between the initial point and the final point of the initial position and the final position of an object. Now let us try to understand these two terms with the help of an example. Now here I have taken a number line and I have marked the distances on this number line in kilometers. So all the distances here are in kilometers. Now if we take your starting position to be position A, which is marked as 0 kilometers, and suppose you have traveled 20 kilometers to position B. So if we want to understand what is the distance traveled by you from A to B, simply it is 20 kilometers. Simply we can say that the distance traveled by you from point A and B is 20 kilometers with the help of this number line. Then what is the displacement traveled? The displacement you had is also 20 kilometers. So in this case, when you are traveling from point A to point B, both the distance and the displacement is 20 kilometers. Now, suppose you travel 10 more kilometers to position C. Now, what is the total distance traveled by you? The total distance traveled by you now is 30 kilometers. See, AC is equal to 30 kilometers. Now again, if we talk about the displacement here also it is 30 kilometers. So in this case also the distance and the displacement are same. Now let us consider that after reaching point C, you decide to travel back to point B. Now if you travel back to point B, then what is the total distance traveled by you? So now the total distance traveled by you, you started from point A, you traveled 20 kilometers to point B. After that you traveled 10 kilometers to point C, and then again you traveled 10 kilometers back to point B. So the total distance traveled is equal to 20 plus 10 plus 10, so 40 kilometers. But what is the total displacement? But the displacement is equal to only 20 kilometers. Why? As I stated the definition of displacement is the shortest distance between the initial position and the final position. Now after you traveled back to point B from point C, now the final position of yours is position B. And what is the shortest distance between your initial point, that is A, and now the final position B? It is 20 kilometers. So your displacement will be 20 kilometers. But the distance traveled by you is 40 kilometers. So this is interesting, that displacement only tells you about the shortest distance between your starting position and the final position. It does not tells you about the actual path taken or the distance traveled by you to reach that position. So I hope this point is clear. I'm repeating once again. You started from point A, you traveled to point B, which is 20 kilometers apart, and then again you travel to point C, which is 10 kilometers apart, and then from point C you traveled back to point B. So the total distance traveled by you is 40 kilometers. But the displacement you had is only 20 kilometers, because when we are talking about displacement, we just see the starting position and the final position. We are not concerned about how you have reached the final position. We just what just matters is what is your final position and what is your initial position and what is the shortest distance between them. But when we talk about distance, distance tells you about the actual path taken or the actual path traveled by you to reach the final position from the starting position. So in short, distance is the actual path traveled and displacement is just the shortest distance, the shortest path between the starting position and the final position. So displacement only depends upon the starting position and the final position, whereas distance includes the total path traveled. Now let us take one more scenario. Now when you are back at point B, you have decided to go back to your starting point. So you go back to your starting point A. Then what is the total distance traveled by you? In this case, the total distance traveled by you, that means from position A you travel to position B, then to position C, then back from position C to position A. This total distance, that means you just took the path back again to point A. The total distance traveled by you is 30 plus 30. So 60 kilometers. So the total distance now you traveled is 60 kilometers. But what is your displacement? Your displacement is 0. Why? Because now your final position is at point A and your initial position was also point A. So there is no distance displacement between your final position and the initial position. So displacement in this case is equal to 0 kilometers. So we can say that displacement can be 0 also. For example, if you start from your house every day, every day you start from your house to reach your school. Suppose your school is at 10 kilometers apart from your home. Then every day you are traveling 10 kilometers to your school and then traveling 10 kilometers back to your home. So every day you are traveling a total distance of 20 kilometers between your school and your home. But your displacement at the end of the day is 0. Why? Because displacement only depends upon your initial position and your final position and not on the actual path taken from your starting position and your final position. So I hope the difference between distance and displacement is clear. Now let us discuss about types of motion in a straight line. So motion in a straight line is of two types. One is uniform motion and the second one is non-uniform motion. Now what do we mean by these both terms? Suppose you started from your house to the market. Just before you started, we take the time to be 0 and the distance traveled is obviously 0. As in when you started to walk, in the first minute, you travel 200 meters. In the next 1 minute, you travel another 200 meters. In the next 1 minute, you travel 200 meters again. And in the next 1 minute, you again travel 200 meters. So if you see, in each minute, you are traveling the fixed amount of distance, which is 200. So this type of a motion where you travel or the object is traveling equal distance in equal interval of time is said to be a uniform motion. So here in each minute you are traveling 200 meters. So you are in a uniform motion. Now what is a non-uniform motion then? Now suppose the same situation where you started from your house to the market, the initial time and distance being 0, 0. In the first 1 minute, you travel 200 meters. In the next 1 minute, you travel 250 meters. In the next 1 minute, you travel 200 meters. And in the next 1 minute, you travel 300 meters. So here you can see that you are traveling different distance in equal interval of time. So in equal interval of time, that means in each minute you are traveling different amount of distance. In the first minute you are traveling 200 meters, in the second minute you are traveling 250 meters, in the third minute you are traveling 200 meters, and in the next 1 minute you are traveling 300 meters. So in every minute you are traveling different amount of distances. This type of a motion wherein an object travels unequal distances in equal interval of time is said to be a non-uniform motion. So in this case you are under a non-uniform motion. So I hope the difference between uniform and non-uniform motion is clear. And before this we discussed about distance and displacement. So I hope everything was clear. In the next class we will be discussing motion in further details. So that's all for today. Take care and bye.